customer-oriented. CFRA Marketing Corporation, the NDT specialist. CFRA Marketing Corporation, your one-stop shop for NDT equipment. NDT, short for non-destructive testing, plays a major role in the broad fields of science and engineering. These fields require accuracy, so equipment has to be reliable, consistent, and tested. And that is where we come in. CFRA Marketing Corporation is always on the front line of distributing high-quality and cost-effective NDT equipment and accessories in the Philippines since 1986. We started off as a sole proprietorship and became incorporated in 6 short years. Since then, our staff has consisted of dedicated and honest professionals who have proficiency and expertise in the commercial and technical sides of NDT. And after almost 3 decades, we have built strong partnerships with end users and prestigious NDT brands. We established our name synonymously with honesty and authenticity. Today, we pride ourselves in achieving sole distribution rights to globally recognized products. This enables us to cater to economic leading industries such as aviation, shipyards, hydrochemicals, engineering, construction, automotive, power plants, and oil and gas. We believe in quality, and we pursue it. And above all things, we value our clients the most. We mold our company around their needs. We do this by providing the latest technology of NDT for a very reasonable price, because we believe that they deserve the best. However, our service does not end there. CFRA commits itself in guaranteeing our customers a wide range of after-sales support from our fully qualified engineers and sales personnel, whenever, wherever, and however. We promise great and reliable service that we will deliver. Quality, partnership, customer-oriented. CFRA Marketing Corporation, the NDT specialist. CFRA Marketing Corporation, your one-stop shop for NDT equipment. NDT, short for non-destructive testing, plays a major role in the broad fields of science and engineering. These fields require accuracy, so equipment has to be reliable, consistent, and tested. And that is where we come in. CFRA Marketing Corporation is always on the front line of distributing high-quality and cost-effective NDT equipment and accessories in the Philippines since 1986. We started off as a sole proprietorship and became incorporated in 6 short years. Since then, our staff has consisted of dedicated and honest professionals who have proficiency and expertise in the commercial and technical sides of NDT. And after almost 3 decades, we have built strong partnerships with end users and prestigious NDT brands. We established our name synonymously
Hello po, good morning po everyone. From Taheo, good morning po. Ma'am Jing. Naririnig po ba ako, Ma'am Jing? Good morning po, Ma'am Jing. Sir Chauvin, naririnig niyo po ako, Sir Chauvin?
Robert, naririnig kita.
Okay.
Sir Bong, naririnig kita.
Okay po, Sir Bong. So, I think wala po atang mic yung mga participants natin from Taheo and wala rin po silang camera ngayong umaga. Pero I believe nakikita naman po nila lahat, no? Sir Bong, pag may hindi po kayo nakikita or naririnig from us, sabihan niyo lang po kami, sir, para ano po, ma-notify po kami agad kasi wala pong communication masyado from Taheo.
Nag-chat ako dun sa chat natin and I'm asking them from tayo if they can hear you. Let's wait if they will reply back.
Opo, okay.
Nag-chat ako if they can hear you.
Sige po, wait po natin.
Yun
Ah,
we
yun.
can hear you po. Ayun. Yun pala eh. So, we will proceed. Yeah.
Okay. Wala po. Hello po. Sir Rian or Ma'am Rian, wala po kayong way para makapag voice po ng makapag-interact po. Kapag question and answer na po natin mamaya, later po after ng ating pong presentation.
Robert, they
Yes,
don't have any microphone daw.
wala pong microphone. So chat na lang po.
Maybe
Chat.
after the chat na lang after the presentation if they have any concerns or chat na lang. Okay?
Okay po. Sige po. Good morning po everyone again. Batiin ko lang po ang ating pong NDT head dyan sa ating pong sa Taheo Cement, si Sir Chovin Chariot, tsaka po si Sir Danny Russell Zafra, and syempre po si Ma'am Jing na isa po sa nag-arrange ng webinar na to for this morning po. To complete po yung ating pong commissioning and training na pin-provide po para kay Taheo. So this morning po, ang ating pong instructor, ipapakilala ko na po. Hindi ko na po papatagalin. Ang ating pong instructor ay si Engineer Gerald Gallardo. Isa po siyang registered electrical engineer, also a welding engineer, and level 3 RTU TPTMT and EDI current certified po, and also currently an officer of Philippine Welding Society, also become president po ng Philippine Welding Society, and as well as a lecturer po sa Philippine Society of Non-Destructive Testing and Philippine Welding Society. So si Sir Gerald po ang ating po magiging instructor sa umagang ito for the basic theory at saka sa mga related topics po para po better nating ma-understand yung ikakandak nating post-weld heat treatment sa ating po mga assets dyan sa Taheo. So everyone, ito po. Welcome po natin si Sir Gerald.
Good morning sa inyo lahat and welcome sa ating continuation of the lecture and commissioning of the post-weld heat treatment machine. However, gusto ko sana makipag-interact sa inyo. Wala yata kayong speaker. So, tatanong sana ako sa inyo kung ano mga problema nyo sa site para doon natin i-focus ang ating lecture. But anyway, gusto ko sana sa inyong itanong ano yung materials nyo, what are the materials being used on your facility, and what are the usual problem na encounter natin, and why we conduct post-weld heat treatment. Okay, to begin with, I'll be discussing some lectures with regards to post-weld heat treatment. So let me share with you my screen. Okay, so Bong Sabida.
Sir Gerald?
Anong pino-post-weld nila ron?
Actually, yung ball mill nila, sir, yung usually ang concern nila doon sa post-weld. So, I think it's a carbon steel material. Then, yung thickness niya yata is above 19 mm. So that's why they required the post-weld heat treatment after the repair.
Okay, so since we don't have any interaction with them, tayong dalawa nag-uusap, I suggest sana may question and answer para ma-appreciate nila yung lecture. Anyway, to begin with, we'll start my discussion on the chemical properties of our metal. So there are many kinds of metal, no? And to start with, buong hirap pag lecture na walang kausap. Tayong dalawa lang. So to start with, in order for us to form, ano nangyari? Bakit? Wala bang nakikita? Ako na. Ako magpo-control. Meron ng slide. Bong, nakikita mo slide ko? Participant.
Yes, sir. Kita ko po. Yeah. Kita ko, sir. In chemical properties.
Okay, so to begin with my lecture, it is very important for us to know what material are we using, no? And basically, in order for us to form a steel, it is basically a combination of an iron plus carbon content. And with this, if you combine this one, and if the percentage of your carbon is up to 2.1%, so we are creating a steel material. So iron plus carbon will make a steel. However, the carbon content, if it increase from 2.1, naging 3%, naging 4%, naging 5%, your steel material will be converted into cast iron. Eh, ano naman ang pagkakaiba noon? So you're creating a material which is a brittle material, mataas ang hardness, and very susceptible to cracking. So when we are conducting post-weld heat treatment, it is very important to you to know what kind of material are you using in order for you to prevent cracking of your material. And the chemical composition will affect weldability and corrosion resistance. So the higher the carbon content, the harder the material, tumataas din ang strength ng bakal. Okay? Mataas ang strength, pero ang kanyang hardness tumataas din and nagiging brittle ang material. So therefore, the carbon content will dictate weldability of if you're conducting welding on your material. Pag mataas ang carbon content, mahirap i-welding ang bakal. Very hard to weld the material, and it will affect the weldability of your project. Okay, so aside from iron plus carbon, you will combine different alloying elements on your metal. What are the sample alloying elements that we are adding to our material? 12% chrome. So your steel will be converted. If you add 12% of chrome on your material, it will be converted into stainless steel. So additional chromium and nickel content will help improve corrosion resistance on your material. And by adding alloy to your material, will create hardness on your metal that will create cracking on your material. So, yan ang nagiging problema natin sa site if we add high carbon content and different alloying elements on our material. And we classify our material into, first, the plain carbon steel, and the second is the low alloy steel and the high alloy steel. So, these are the different materials, and we will concentrate, since our topic is about heat treatment, I will concentrate my discussion on metals only. So we'll now segregate the non-metal materials, and we classify metals into two groups. These are ferrous material and non-ferrous. What are the ferrous material? These are steel. So ano yung steel? Iron plus carbon up to 2.1%. As you increase the carbon content, tumitigas ang bakal, you will increase the hardness, you will also increase the strength of your material. So, challenge ang welding if you're increasing the carbon content. Okay? So before nga pala we proceed, no, ay hirap mag-lecture nang walang kausap. Can you chat in the chat box if you have questions in order for us to have interaction? Mahirap yung one way, no? Dapat two-way tayo para maintindihan natin yung ating topic. So these are ferrous material. And non-ferrous material, if you use tin, lead, copper, bronze, zinc, these are heavy non-ferrous material, while the light non-ferrous are aluminum, duraluminum, and hydroaluminum. So these are different materials that we will encounter in our projects. Okay, as I mentioned to you, steel is composed of 98 to 99% iron. Tapos mag-add ka ng carbon content to a maximum of 2.1%, you're creating steel. And what are the different elements present in our steel? There are certain maliliit na amount or small amount of silicon, which is 0.15, manganese, phosphorus, and sulfur. If we add all these elements, chemical elements, we're creating a steel. Yung may mga X, if you add that one, you're creating a steel. Magiging low alloy steel yan and high alloy steel if you add alloying elements. What are the different alloying elements? The red color chemical elements are considered as alloying element. If you add certain percentage of nickel, like 12%, you will convert your steel into stainless steel. This nickel content help you kung meron kayong material, ayaw nyong kalawangin or you need to avoid corrosion, you need alloying elements such as nickel and chromium. What is the difference between nickel and chromium? Chromium, you use this at high temperature application. So you usually use this in a power plant between the turbine area, going to your boiler. So mataas masyado ang temperature. Okay? And then you need to add certain molybdenum, vanadium, manganese, and tungsten. If you have these certain alloying elements in your material, originally plain carbon steel siya, but if you add this element, you will convert to low alloy steel and high alloy steel. So these are the different materials you're involved. If you're a welding engineer, a welding inspector, that you need to know in order for you to check if the material has a problem on the different mechanical properties. What are the different mechanical properties? Strength ng bakal. Second, toughness of your material. Ductility of your material. So these are the different mechanical properties that will be affected depende sa chemical content of your material. Kaya for post-weld heat treatment, it is very important for you to know what kind of material are you using in order for you to prevent welding problems such as cracking of your material. Okay, nakakaintindihan ba tayo? Robert, sagot ka naman kasi mag-isa lang ako rito. Wala akong kausap.
Yes, sir. Yes, sir.
Okay, sir.
Hindi ko na visualize kung naiintindihan nila yung sinasabi. But anyway, so in creating steel and iron kanina, as I mentioned to you, up to 2.1%. Iron plus carbon, up to 2.1%, you're creating a steel. And if you increase the carbon content up to 5%, you're creating a cast iron. What is the difference between steel and cast iron? Cast iron, mataas ang hardness, mataas ang strength. While your steel, so if you increase the carbon of your material, it will increase strength of the materials. Okay, tataas ang strength of your material. However, it will be indirectly proportional sa hardness o sa ductility of your material. So tataas nga ang strength but the ductility will be affected. Ano ba yung ductility? Ability of your material to be stretched at certain temperature and certain pressure. Okay?
Gerald,
Yeah.
doon sa presentation niyo, sir, yung 2 to 3%, yung under ng iron, yung sinasabing nakalagay 1.5% not usable. What do you mean by that, sir, na not usable? The material itself, yung bakal?
If you combine iron plus carbon up to 2.1%, that's steel. Pero kapag ang iron content tumataas up to, actually, yung hindi masyadong ginagamit yung 1.5%
Carbon, sir.
in commercial commercial steel. So, hindi applicable masyado, no? So, however, ang gusto kong emphasize dito, ano yung effect sa post-weld heat treatment as you increase the carbon content. If you increase the carbon content, tumataas ang strength, nagiging brittle ang material. So, therefore, lagi mong magiging problema, cracking of your material. Okay?
Okay, sir.
Okay, sir.
Mataas din ang strength. However, bumababa ang ductility of your material. Ano yung ductility? Yung certain, yung tendency of your metal to be stretched. So, hindi na kagad siya nag-i-stretch, napuputol na kagad or nagkakaroon na kagad ng cracking. So, meron mga bakal na kailangan i-apply mo. May certain ductility and toughness. So, katulad ng mga pressure vessel. So, we want to achieve ductility and toughness of your material. Ang isang magandang example dito is Titanic. Kung napanood niyo yung movie ng Titanic, ang sabi ng designer, my ship is unsinkable ship because I use a high-strength steel. However, metallurgists at that time, hindi pa na-discover na ang metal subjected at low temperature application, and this is during winter time. So, yung Titanic nagta-travel sa North Pole, winter time. So, ang bakal pala na mataas ang strength, ibig sabihin mataas ang carbon content, bumababa ang absorbed energy at low temperature. So, nung bumangga siya sa iceberg, instead na ma-dent or mayupi lang yung wall ng kanyang Titanic, naging brittle siya, kaya pumasok ang tubig na basag. And to exaggerate what is brittleness, yung ating bakal parang nag-behave like glass, no? Nung nabangga siya sa Titanic, nabasag yung ating material. So at that time, hindi pa alam ng mga metallurgists yan. Kaya sabi nila, in designing certain application, you need also to combine ductility, not only the strength of your material, but also toughness of your material. Okay? Ano ba pagkakaiba ng strength sa toughness? Strength is force over area, while toughness is the ability of your material to absorb impact energy. So, nag-subject sa overpressure, ang ating material hindi kaagad nagbe-break. Nagkakaroon lang ng dent lang siya, nagkakaroon lang ng yupi sa ating bakal. And there are some application, gusto ko nga makausap sana yung tayo o anong application ng kanilang bakal para magkaroon tayo ng failure analysis. Saan ba nanggagaling yung kanilang problema? And unfortunately, one way lang tayo, nagsasalita lang ako, hindi ko naman sila marinig kung ano yung mga concerns nila para ma-address natin yung problema nila sa site. Okay, so carbon is a principal hardening element of steel, and it determines if this is a steel or a cast iron. Okay, so cast iron is between 2.1 up to 5%. You are now creating a cast iron. Okay, so sabi natin kanina, we have a steel and this one is a cast iron, no? So the cast iron are the gray cast iron, malleable cast iron, white cast iron, and nodular cast iron. Ito mahirap i-welding kasi masyado ng matigas. But kaya pa rin i-welding yan. using a special welding electrode and by applying heat treatment. So tayo papasok ngayon sa topic natin na heat treatment. So if our material is steel and we have the plain carbon steel, kanina, yung walang halong alloy, the plain carbon steel are classified into low carbon steel, medium carbon steel, and high carbon steel. If you notice, nandiyan yung 0.15% carbon steel, these are considered as low carbon steel, while the mild steel or the medium carbon steel is up to 0.5%, and the high carbon steel is 1.5. If you compare weldability o yung process of welding, medyo mahirap mag-welding sa medium carbon steel at saka high carbon steel. But you need to prepare a welding procedure specification in order for you to achieve weldability. Ano ba yung weldability? The definition of weldability in accordance to American Welding Society, it is the ability of your metal to be welded without any failure specific to the design of your material. So if we interpret this, if we have a project like dyan sa Cebu, where building a new bridge, no? Yung bago yung bridge dyan sa Cebu. And we use a high carbon steel. So medyo mahirap i-welding ang high carbon steel, but you need to prepare a welding procedure. So we conducted actually a training for the engineers of the one constructing the longest bridge in Cebu, and not only in Cebu, but now in the Philippines yata, no, the longest bridge, on how to successfully weld these bridges, and this is under the Philippine Welding Society. So the effect is, habang tumataas ang carbon content, as you increase the carbon content, the harder you achieve weldability. Ano ang weldability? Ma-fuse mo yung metal without any failure. If the bridge is designed 20 tons, dapat yung welding natin, kapag may dumaang truck load na 20 tons, it will not fail based on the design of the bridge or based on the pressure designed as a pressure vessel or based on the working temperature of your material. So walang failure na mangyayari kung nasa-satisfy natin yung design pressure, design temperature of your material. And that's weldability. Robert, pakitignan yung chat box, baka nagtatanong sila para interrupt mo ko. Kung meron silang tanong.
Sige po.
Kasi hindi ko nakikita. So these are the different common steel used in different projects. Low carbon steel, 0.15%. These are the typical use and very easy to weld. While mild steel and medium carbon steel, medyo madali pa siyang i-weld, but you need to preheat the material. However, the high carbon content, you need special welding procedure in order for you to achieve weldability. Okay? So, kailangan walang failure. So, may certain ductility, may certain toughness, and strength of your material. Any other question? So, as I mentioned to you kanina, no, we're using different chemical elements, and we need to trace back what are the different chemical elements during our chemistry days, no? So if you combine two chemical elements, it will form into certain material. So iron plus carbon will create steel. And if you add certain alloying elements such as chromium will create stainless steel, manganese. Ano ba ang tutulong ng manganese sa steel? Maganda yung grain refiner. And if there is a certain manganese content in our material, ito yung na-discover ng mga metallurgists, no? If you add manganese, you will produce toughness and ductility on your material, no? So, sabi natin kanina, hindi lang strength is the consideration, but also the toughness and ductility of material. And molybdenum, it will create hardness, it will increase hardness, and it will also contribute toughness of your material. And these are good for high temperature in order to avoid creeping resistance. Kaya in power plant, there are combination of chromium and molybdenum material, no? Because molybdenum is good for high temperature, pati rin yung chromium content. Okay, so nickel is also increasing the ductility and maintaining the strength of your material. Vanadium, it is a grain refiner. So in metallurgy, you need to check or inspect for the different grain boundaries of your material. And iniiwasan natin magkaroon ng coarse grain material. Because if you have a coarse grain material, you will have a martensitic material. Ano yung martensitic? Mataas ang hardness, kaya nagkakaroon ng cracking ang material. Toughness. So tungsten is adding toughness and hard and wear resistant. Cobalt combined with tungsten will improve the red hardness of your material. And kanina na-mention ko na sa inyo yung carbon. The higher the carbon content, the more strength of our steel. So these are different elements when added to your material will change mechanical properties. And what are the mechanical properties that will be changed? First is the strength of your material. Second, hardness of your material, ductility, and toughness of your material. And nandun pa yung panglima, fatigue strength of your material. So, sulfur is also needed. Sulfur and phosphorus, these are impurities. However, if you exceed sulfur and phosphorus content, it will create laminar tearing and hard cracking. So you need to control these impurities. Okay. So if we have a material, makikita nyo yung sa kanyang mill test certificate, kung bumili kayo ng certain steel, say for example, the high carbon steel, malalaman mo yung yield strength, which is 90,000 pounds per square inch, at pati yung ultimate tensile strength niya na 140,000 pounds per centimeter squared. And also the ductility, which is 20% for every 2 inches elongation or the ductility of your material.
Sir, may tanong.
And the maximum is 310 BHN. Yes, sir? Any
Sir, may-
question?
Meron ba kayong standard or table sa mga steel temperature or material composition?
Ako ba tinatanong mo o sila?
Sila, sir, nirepresent ko lang. Meron silang, so meron silang standard or table or material composition.
Dapat alam nila kung ano yung materials na ginagamit nila sa ball mill para malaman nila kung ano yung yield strength, tensile strength, naka-design na yun. So, bisan kasi ang failure, bakit kailangan natin malaman to? Dahil ang failure, nanggagaling na due to overloading. So, may factor din yun. Kanina, pinag-uusapan natin, ano ba yung effect ng chemical elements sa ating bakal? Naapektuhan ba yung mechanical properties such as strength, ductility, toughness of your material, hardness? No naman, kaya ko sinasabi itong, alam mo dapat yung yield strength at saka tensile strength. Baka naman overloading na ang problema, kaya nagkakaroon ng cracking. Okay? So that's the purpose why I mentioned to you what is the effect. So nalaman na natin kanina sa mill test certificate kung anong klaseng bakal siya. And then sa mill test certificate din nakalagay yung yield strength, tensile strength, elongation or ductility of your material and your hardness. Okay, these are different classifications of steel. Na-mention ko na, low carbon steel, medium carbon steel, and low carbon or low alloy steel, and the high alloy steel. So the austenitic stainless steel is an example of a high alloy steel kasi meron siyang 12% chrome alloying elements, and this is very prone to heat cracking. Okay, so what is carbon equivalent for weldability of steel? Meron ka nakikitang CE, this means carbon equivalent. And if you have a mill test certificate, so may formula in accordance to International Institute of Welding, carbon plus manganese divided by 6 plus the combination of chromium, molybdenum, and palladium. Total mo yan divided by 5 plus nickel and copper divided by 15. And this one is another carbon equivalent for low carbon steel. So ganun din, kukunin mo rin yung carbon content, silicon, manganese, chrome, nickel, molybdenum, and vanadium divided by yung mga factor niyan, 16, 20. At kapag nakuha mo na yung sagot niyan, yung sum niyan, yan mo malalaman kung kailangan i-preheat ang material. So if your answer is less than 0.14%, walang problema sa welding, madaling i-welding. If your answer of carbon equivalent is up to 0.45%, you're creating a martensitic material. And martensitic is mataas ang hardness. You need to preheat and use a low hydrogen welding electrode. If it exceeds 0.45, these are very hard and complicated material, and very likely if you conduct welding, cracking will occur. You need a preheating, you need to preheat, and you need to conduct post-weld heat treatment or stress relieving process. So these are the typical preheating temperature, depende sa carbon content. Kaya pinakita sa inyo yung formula para malaman natin, before welding, itataas mo muna yung temperature between 93 to 200 or 150, no? Bago ka mag-start ng welding. If the carbon equivalent is 0.45 after. Yeah.
Sir, tanong ko lang, kasi dati nagkaroon tayo ng experience before dun sa isang client natin na nagkaroon ng issues dun sa low hydrogen cracking after doing the post-swim. Nag-conduct tayo. Parang nagkaroon ng cracking yung kanilang welding. So parang nagkaroon ng investigation that time. After nung welding nila, pinakondak agad sa atin yung metal. Tapos yun nga, the next day, nagkaroon ng parang cracking dun sa welding. And after thorough investigation, parang ang nangyari yata, lumabas na parang low hydrogen cracking yung naging issues.
Hindi Bong, hindi low hydrogen. Ang kailangan mong gawin doon, magkaroon ng hydrogen bake out. Yung lumabas sa kanila is delayed cracking or cold cracking. Bakit ba tinawag na cold cracking? Your crack will occur 48 hours after welding maximum. So delayed cracking siya, mababa na yung temperature niya. And problema yun dahil merong na-trap na hydrogen content inside our solidifying metal, no? So, saan ba nanggaling yung hydrogen? And hydrogen pwede manggaling sa environment because may moisture, mataas ang moisture content, especially if you're malapit ka sa dagat. So ano bang moisture content? Di ba? H2O yon. So mag-evaporate ang oxygen, may iiwan sa ating welding ang hydrogen, tapos hindi na preheat or kulang sa preheating, nagkakaroon ng trapped hydrogen inside our weldment. And dito, ang normally tawag dito, underbed cracking. So, delayed cracking yan. Para mawala yung delayed cracking, sinasabi ng mga welding engineer dyan, kailangan magkaroon ng hydrogen bake out o kaya preheating. So habang nagwe-welding ka, before you weld, you need to raise the temperature at halimbawa 150 degrees centigrade. Ano naman ang difference ng preheating sa intermediate post-heating? Sabi nga natin, 2 araw daw bago lumabas yung cold cracking. So you need to conduct post-heating. Halimbawa, nasa 150 degrees centigrade siya, no? Tapos na yung capping, na welding na natin siya. Itataas pa natin yan na dahan-dahan hanggang 350 degrees centigrade. Isusok natin ng 1 oras and then dahan-dahan din ang cooling. So pag nagawa mo yung post-heating, ang waiting time mo sa delayed cracking na-shorten from 48 hours nagiging 24 hours or 1 day na lang. So,
Sir Gerald, yung reference mo pa rin sa material na yun, depends dun sa, yung sinabi nyo nga sir, yung carbon equivalent ng material. Para dun
kailangan i-check mo yung carbon equivalent para alam mo kung ipipreheat yung material.
Yes, para dun sa sinasabi nyo ma-mitigate yung concern dun sa mga cold cracking or something like that. Na dun sa ma-establish nila yung procedure nila for tayo if in case mayroon silang ganung material.
Yes, sir.
Okay, sir. Thank you.
So, you need to, minsan yung mga, ang given degrees Fahrenheit, no, you need to convert to centigrade. So, there is a formula, 5/9 multiplied by F minus 32. Yung sagot doon, multiplied mo na 5 divided by 9. So, mako-convert mo siya into centigrade. Okay. Sa welding, very important for you to control heat input. Kailangan mas mababa yung heat input kung ano lang yung required ng ating bakal na heat input. Huwag naman yung sobra-sobra. Kasi bakit? Pag tumaas ang heat input mo sa bakal, nagbabago ang metallurgical properties, pati ang mechanical properties. Ang bakal, kung nabili mo ng annealed, pag sinabing annealed, soft, and ductile, pwedeng tumigas yan kapag nagkakaroon ka ng heat input sa ating bakal na sobrang taas. So pag nag-welding tayo, normal carbon steel, tinataasan natin ng temperature ng 1,400 degrees centigrade. So mataas, no? Tapos biglang lalamig. Ano ba yung ambient temperature natin? 30 degrees? So there is a great temperature gradient from 1,400, biglang naging 38. Ano tendency ng bakal kapag pinalalamig mo ng mabilis? Tumitigas ang bakal. So mamaya, i-discuss ko sa inyo the different heat treatment, and each heat treatment will create different mechanical properties. O gusto kong tumigas ang bakal, anong gagawin ko? Palamigin ko ng mabilis. Gusto kong kunat or toughness of our steel. So, dahan-dahan kong palalamigin ang aking bakal para ma-achieve ko yung certain toughness of our material. And in welding, heat input affect toughness or the properties of our carbon steel. So, aside from the toughness, it will also affect bumababa ang corrosion resistance if you introduce sobrang taas ng heat input. And this is the reason why some projects nakakatatlong repair na, pang-apat, ayaw na paggamit ang material. Pagdating ng R3, cut out na, then because the material will change the toughness or the mechanical property affected is toughness of your material. Okay, so it will change the microstructure of your weldment material, and it will affect quality and mechanical properties of your weld, such as toughness and corrosion resistance. And the value of this is kilojoules per inch or kilojoules per millimeter. And the formula for heat input is a voltage, an arc voltage of your welding machine multiplied the current setting of your welding machine multiplied by 60 divided by travel speed. Saan ba yung arc voltage? This is the distance between your electrode distance to your material. So habang nilalayo mo yung distance ng ating electrode sa ating material, bumababa ang arc voltage. Kapag nilalapit mo naman, tumataas ang arc voltage. Okay, so much on that. So if you want to compute the heat input of your material, so a welder welding at a speed of 25 inches per minute, at ang iyong welding machine has a 25 volts, and the current setting is 110 amperes. By direct substitution to our formula, you will compute 6,600 joules per inch or 6.6 kilojoules per inch ang ating heat input in our material. Okay, in a European standard, sa American standard, ito lang, no, voltage ampere multiplied by 60 divided by travel speed. Sa Europe, kinukuha yung thermal efficiency ng welding process. Ano ba yung different welding process, no? Sa TIG, 0.6, sa plasma arc, 0.6, sa GMAW or gas metal arc welding, 0.8, sa flux cord or FCAW, 0.8, sa manual metal arc or SMAW, 0.8, at ang sa merge arc is 1. So ang pinakamababang heat input pala is TIG and plasma arc. Dating sa SMAU or manual metal art is 0.8. Pinakamataas ang heat input na nakikreate sa merge arc welding. So yung factor na yan, sinasama sa formula, thermal efficiency, para makompute natin ang heat input. So that will end my topic on the chemical composition of your material.